My name's Eric Proegler. I've been a member of AST for a few years. I'm probably most known in our community for being an organizer for Whopper. It's a peer workshop. We're going to do our 23rd this fall, so if you're doing peer workshops, we should talk. The last Whopper we did, we talked about this subject. So the people who participate in that workshop are credited here because this is how we do attribution for people in a peer workshop. Everybody there participates in what happens in that peer workshop. So I'm going to talk about iterative development, and I picked one picture, but I'm not too interested in that because I'm not into debates over what things are. And to be honest, my experiences with iterative development have been process police trying to shove something in place that wasn't working. So if I have a trademark on scrum baggery, although feel free to use it without attribution to make my property worth more. The important thing is that our more contemporary development contexts value quick feedback. And for performance and scalability testing, that's a big challenge, and that's what I want to talk to you about today. So how do we make performance testing provide feedback faster, even when the system isn't complete yet? That's something that other kinds of testing and checking solve. How do we do this with performance testing? This is my index for our session today. I'm going to be watching the time, so I've put the stuff that's the most fun to talk about first. So I want to talk about the risks that we address with performance testing. There's a reason why people do this. There's a perceived risk that is often cast in terms of brand and losing customers because that helps the business understand why we're doing it. But from an engineering standpoint, I have 4 specific risk categories here to talk about. Other formulations exist. These are the ones that I use. So the first risk that I'd like to address with performance testing is scalability. If we do something and it takes a long time, not only will the users be unhappy with that feature, but it's likely that operation is expensive. And that's going to cause a challenge for our system to scale. The idea in a multi-user system is that we keep most things light enough that we can do a lot of them at a time. That's how these things work ever since we were working on client-server in the 90s and then the internet happened. I'm a big fan of Wirth's law. The software is getting slower more rapidly than hardware gets faster because of how the nature of software development has changed. The number of interpreted languages and stacks that we're pushing through actually means that most things are slower than they used to be. So how do I know when I've got a problem like this? Well, the long response time for an activity is usually a really good clue that something's going on. Something somewhere takes a long time. And I don't need to put a system under a great deal of load to tell that. But if I run an activity and I see a server CPU blip to handle it, that might tell me that I've got something there and that maybe I should run load to see how quickly I can make it bad. We test for capacity, and this is what most people who aren't performance engineers are thinking about. They're thinking about, can I fit 8 quantities of computing into this 6-pound bag of virtualization, and how is that going to work out? So when you're running into a capacity problem, it's going to be response time that appears sensitive to load. There are a lot of machine-level metrics and soft resource metrics that measure queuing. When those build, that's an idea that maybe the system just doesn't have the capacity for that. I've spent too much time trying to reproduce concurrency bugs. And these are the kinds of things that occur apparently under load. When in a previous life when I worked for a software vendor, there were many late nights where some customer had this problem twice in 3 weeks, and we needed to reproduce it so we could fix it. Or we got a process dump from when it did happen at the customer site eventually, after all that pain, and now we needed to verify that we didn't have the problem anymore. These are hard problems to solve, or hard problems to detect. Once you can quantify them, they're still hard to solve. Although these days developers are getting pushed farther up the stack and they touch this kind of code less and less often. And then last, reliability. As a system is up over a period of time, does it degrade in terms of response time or resources? Managed memory means that you still leak memory, has been my experience. That somehow, somewhere, you're going to not continue to return your memory space to where you started. Over time, you'll become that Java process or .NET process becomes less and less efficient. More CRUD builds up in it, and that can have an effect on response times and in the capacity of the system. When I first started working with .NET software, when you set it up, the .NET IIS stack, it had a default restart every 1,740 minutes, which gave you an idea of how long Microsoft expected a .NET process to last. And even today, there's still a lot of SaaS providers who will say they have a certain number of nines in their uptime, but they have scheduled maintenance every night from 2 to 4, for example, and that's to recycle these processes and reset those things. So now that we know what we're talking about, let's look at one of the assumptions that has been made in traditional performance testing, is that we're going to test a realistic thing. There's this model where we're going to build this one big simulation, and it's going to have certain types of users doing certain types of things, and we'll come up with some rate at which they're going to do it, and we're going to have some configuration that's going to be just like production, and we'll run the simulation. It will tell us everything we need to know. Everybody's ass will be covered, and we can go live. There are a number of problems with this. I'm going to call this a simulation test to distinguish this particular kind of load test from other kinds. Now, for starters, we have a heavy use of models in these. We guess at which activities we're going to test. We can't test every activity in a system typically in a performance test. There are some exceptions where people are able to play back log files, but definitely up until recently, just about every performance test was this sort of model that was some subset of 80-20 rule against what people would be running in their system. Real systems have organic loads and arrival rates. The number of users connected to the system goes up and down over time. Sometimes a lot of people come on at once. Sometimes they come on slowly. Load tools don't support that kind of tuning. It's pretty typically a ramp up to a level, and you're going to stay there for the rest of the test. Load tools don't handle the people who get up and go have a cup of coffee, or have somebody stop by and start talking to them, or who just get bored and walk away. These are things that affect how systems perform, but they're not anything we account for in our simulation tests. And there's a lot of issues with the data being accessed in a load test against what users would access. And we're also full of it about the idea that the environment will be realistic. There are a number of ways that this breaks down. Everywhere I test these days, there's shared resources, at least a SAN and virtualization to deal with. The systems I test that are in the cloud becomes very difficult to have any sort of discrete resource pool. So the way we did it before, when there were dedicated servers for every project and there was a rack with this many of them, is I know what my quantity of CPU I have available to me. I'll measure how well my test does in using that and how much I have left and make a projection as to how things are going to perform when they go live. That's very difficult now. Once the resources are shared, you have the problem of other activities and other systems contending for them. Virtualization is a real problem for having a consistent resource pool. And more often than not, and my experience with my clients is they have too much stuff shoved into virtualization for a load test at least, and probably for most production work, that they have periods of slowdown that are due to resource overcommitment. And the virtualization vendors, to manipulate their ROI calculations, invite their customers to overcommit their resources greatly. Oh, don't worry, you'll never use those systems that much. Just add up a bunch of averages and size base to that, which causes big problems when you're trying to carefully examine resources and capacity and what's available. More and more of my customers these days have people working from home, people working over wireless, people working in different countries, and those people's experience is going to be very different than the person sitting in the office. That's something the traditional simulation didn't accommodate well, but we can work with a little bit now. So let's talk about some techniques. What can we do to engage with this new context besides trying to continue to run a big, expensive simulation at the very end of a project? So maybe the biggest indictment of the traditional simulation test is it comes at the very end. It's the part that's still waterfall, the way most people think about things. It's a big problem that everybody who's anywhere near IT thinks they know how to test correctly. They're even farther behind the curve on performance testing. Even people that do understand testing throughout a project still think, okay, we're going to go live on that Monday, so the Monday before we need to run a load test. And then we'll know whether we need to go live or not. So what happens is you find a problem, and then it gets triaged by people who have bonuses on the line, who have prestige on the line, and sometimes jobs on the line. So the deferred to phase 2 for problems you find in a load test is a pretty typical pattern. The reason we can't just do simulation tests more often is that they're so expensive to create them, to script a number of activities against a system. It's something we do elsewhere, but performance testing usually as a small team of 1 or 2 people. Once those scripts are created, there's the maintenance issues that all sorts of automation have. Load testing kind of locks you into some specific script interfaces, so you can't take advantage of abstraction and other techniques that make automation easier to live with over the life of a project. You kind of have this list of activities, and if something changes in the interface, you have to go back in, figure out what it is. Often, the load tool pushes you towards just starting over and then having to copy and paste in. It sucks. And then you run one of these big simulation tests, and you have to kind of look at it. Sometimes 24 or 48 hours is the amount of time it takes to look at a complicated load test and make sure you're confident in the results, make sure you understand how many errors occurred, make sure you understand what you saw in resources and response time to be able to report conclusions that you're confident about. So it's a lot of react time from when my test's finished to when I can tell you what my feedback is and what actions I think you should take on it. So one approach that I have used is to go the other way and say, all right, instead of going complicated, let's go simple. Instead of an expensive test, let's do cheap tests. And I can do a lot of them, and then I can do them whenever I want. Instead of trying to measure and recreate a very complex situation, I'll just do a real simple one. And that helps when the software isn't complete yet. So I'll talk more about specific use cases a little bit later. The horizontal scalability comment here. Think about it in terms of how many solutions have 4 web servers. And then capacity is whatever the capacity is of one web server times 4. So throw away the other 3 web servers. I don't feel like testing a network appliance early on in a project. Let's pick one server, let's figure out what it can support, and calibrate on that. Calibration is another important concept I want to talk to you about. But if I have one server that I run tests on that I can keep clean, I should be able to tell you over the course of our project whether we're doing better, whether we're doing worse, what the cost is of this new session object, and as the project evolves, continue to provide feedback throughout. So some examples of the kind of use cases I would use are login. I've done really great tests where all I did was create a session and log off. Because as a system was being developed, as more and more things got thrown into session buckets, or as refinements were made to try to undo some of the crappy stuff that happened, this was a great way to measure an expensive activity. The login has always kind of been known to performance testers as something with a long response time, something that usually has a lot of resources involved because of everything that's going on behind the scenes in terms of checking data stores and spinning up objects in memory and all the things that have to happen. Simple workflows where you do a couple things and log back out again. Remember, at this point, I'm thinking about these use cases in terms of measuring progress and then running this test again tomorrow and seeing what's changed. Are we getting better or worse on performance during the test? Have we already found something bad? If I go to start out with a login test and it already takes 20 seconds to log in many contexts, that's not going to be acceptable. And then as the project is evolving, even as basic security controls are added, that login time tends to fluctuate greatly. So it's something we can keep track of. In addition to response times, there are other metrics to keep that you can track in a load test, such as the size of requests and things like that. I've also found that to be helpful to developers I worked with. And if you find a problem, then you can dig into it farther. Login is twice as long as yesterday. Well, why is that? I can use other tools to dig into that further, and then by the time I talk to the developer, I can say, hey, you know that third service call you make, now it's taking this long because it's this big, because there's this one big object that you're pushing back and forth to the client. That makes it easier to provide actionable feedback to the developer. So now that we're getting rid of real, we can have some real fun with our load models. So who needs think time? I'm not trying to be real anymore. I'm trying to measure how a system handles performance. In some cases, removing think time is going to help me have a better understanding of what's happening, particularly if I have a limited number of iterations. The 10 by 10 test, I think I did some of my best work as a performance tester running that kind of test over and over again. The CTO of a company I work for looked at a bunch of load test results I'd given him, and I talked to him about the problem. He said, you know what I just want? I want you to, every month, I want you to just run this, he called it a slam test, and tell me whether it's worse, it's faster or slower. So 10 threads, 10 iterations of logging on and logging off. I started running that every month. Then sometimes more often when changes were being made because I was finding problems with it. With no think time, I'd run a 17-second load test and keep track of how long that took. Well, it only took me 17 seconds, so I can run 20 of those in a row and average those. And over time, I built up a pretty good system for getting a statistically significant measurement in an hour or two of how we were doing on a lot of the common activities in the software. One thread, 100 iterations, is a way to make small increases in response time appear larger. But if they're so small that you're not sure if it's a measurement thing or an outlier, if I have 100 activities and then my whole test ends significantly later than it used to, then it's pretty clear that something's going on there. So those are the two tests I would report the most often. And the last test model there to address the problem of decay and degradation in a system's performance was to run a test for a very long period of time. These are typically called soak tests, and these are nothing new. What I like to do with that was to run 10 threads with some sleep time so they wouldn't use a lot of CPU, but just 10, 20% CPU, turn it over, go set that up on the machine in the back corner of the test lab, and let it run indefinitely sometimes. And it was a really great thing when we get it to run for 2 weeks, and when it broke after a couple hours, then we knew that we had found a leak. And then it was very quick to get things started. So we got to the point where we had that test running most of the time, because whenever it broke, after however long that took, we would just put the latest day's build on it and start it again. So if it lasts for a while, maybe we get to jump way ahead in things, and then you can do a bubble sort to get back to the build where something broke if you find a build that has a problem. And that's sort of the same approach with the other kinds of loads I was talking about. I have daily builds. Maybe I don't test the build every single day, but once I've discovered there's a problem between this build and this build, I can find where it was introduced, and that certainly speeds up the developer resolving that issue. So it's about halfway, Eric? Okay, thank you. Okay. So now, while we're getting rid of old assumptions, let's get rid of the comparable environment. We have the one server. Why do I have to have it set up on 5 different machines? If what I'm trying to detect is a delta or a difference in how things performed one day to another, it might be easier to detect if I have all of the components on a single machine. So if a presentation layer or a business logic layer or a database server, if any of those things get slower while I'm running this load, that will help them pop out to me. When I have a distributed system, it becomes harder to untangle that. And maybe the bigger value out of that was the isolation. It allowed me to have the one machine that was over in a corner that I could turn off Microsoft patching on, that nothing else would change, and I would have a clean environment. That I felt comfortable with my instruments. I felt comfortable that if something went wrong, I can do a spot check, but I'm probably going to be okay. I'm not going to be embarrassed when I go to the development manager and say something's wrong, and then end up later on going, well, I could have sworn that's the number I got, which is a risk for performance testing, which is a risk that you don't have a lot of credibility at first, and you should keep a close eye on it, because if you deliver bad news, you need to be trusted. So the calibration idea, every month before I reran the set of tests, I would start with last month's build and still make sure I got the same results again. And if something changed, I better figure out what it was. Resolve that, and then I'll be able to move on. When a server crashed and we need to move to a new server, take the same build, recalibrate from one to the other, and measure that difference, which helped put subsequent results on the new server in context. These tests are fast enough that I can continue to recalibrate my performance numbers and my resource numbers, make sure that my measurements are trustworthy. So I run many tests and average results across them, instead of one simulation where sometimes stuff happens. I ran a traditional load test about, I guess it'd be 6 days ago now, where something had been left running, and this test started out slow, and a bunch of virtual users crashed, and then they fixed it, but because the data was consumable, we needed to just push through and get to the other side. So we had these ugly test results. We didn't have as many users running as we wanted, and it was kind of, well, we still learned something from it, and we're going to go retest that as soon as I get back from cast, actually. If I could just run that test again, and if it had been cheap enough, I would have results I felt much better about. If I can run a test in a couple of minutes, I can sit there and press start, write down the numbers, press start, write down the numbers, and aggregate my results from those, and quickly get some significant data. If they're that fast, I can run them every day. Now, I don't know much about running tests and continuous integration. I hear people talking about it. People are excited about it. Performance testing and continuous integration is something that the cloud-based load vendors are definitely selling. And the traditional load vendors would say, hey, I have a scriptable interface. You can run our stuff in CI. It seems to me it would be pretty difficult to do any complex tests, but maybe some of the simple tests I've described you could do. Does anybody have experience with performance testing in CI? You got a microphone? Sorry, I should have warned you.
Can you hear me? Yeah. Oh, okay. So we have a web application that is comprised of many, many services that are all built by different teams. And the interesting thing is that in our nightly continuous integration, we run performance tests at the component level. So I might throw 1,000 requests at my API and see what the response times are, and we track those on a daily basis. At the end of the test, because the nightly testing takes way too long, we do a CAN test of user response time. We measure server response time. We do measurements on the database and that kind of thing. And it's just, you just have to make sure that you know how long it's going to take you to run it. And then we just have, we use Team City to compile the report and throw it up on the dashboard.
So it's a load tool generated report?
No, the load tool that we have, we actually wrote it ourselves because it's just way easier to measure what you want to measure that way.
Yeah,
so
that's nice. I could take one or two more comments if anybody has some direct experience.
Hi. Yeah, I've been using Jenkins and Grinder to do a similar thing, but I do simple tests, the 10 by 100 type test. It runs in about 20 minutes. I try to run it every night through Jenkins or when I've got a new build going out. And I find it does say it's the same thing you're going after. It lets people get a quick snapshot of deltas. And I use I customized a Jenkins plugin, so I've got a very simple time chart with error bars so people can quickly see from day to day what's happened and the change in overall test time and stuff, so they get a quick idea. And managers seem to like it too.
That's very cool.
Yeah.
And confirmatory.
Yes.
One more? Do you see more hands?
Yeah, I worked for a team where we worked on a framework, and it wasn't exactly continuous integration, but it was a lazy system. So whenever somebody checked in, it would trigger just a build, and it would run a whole set of micro benchmarks. Not so much load testing, but very small API level. Run the test 100 times, whatever. But it was a pretty large suite. The biggest issues that we ran into was that, usually for CI, to reject a check-in, you need some sort of a pass-fail. And you can't really do that, one, because it's a performance test, and two, because it was a lazy system. We weren't really gating check-ins. But the other issue was one of creep, because we had goals set. So each test had a certain goal that it had to be under a threshold, but you have to be very cognizant of potential small increases that pile up over time, because then once it passes over that threshold, it's a failure, but then you have to go back and try to determine which is the change that actually caused that problem. Which
it was 2% slower than yesterday, and
and those things add up, small, and then finally goes over the threshold, and you might not have the build again or something like that. So that's where it gets a little bit sort of dangerous.
I appreciate sharing your experience. That's an experience I haven't had yet, so thank you. There's some other techniques for performance testing I think that anybody can do. There's a lot of pretty good open source tools these days for load testing. Jmeter is probably where I would point most people to if they're starting from nothing. But even without tooling, or at least that kind of tooling, you can look at the performance of a system. I was able to sell some performance bugs to people with stopwatch measurements, or making them watch the software on two comparable laptops. We were introducing a new client that was supposed to overlap with a web client. It was that Microsoft Xboxy stuff. I'm trying to remember what the name of that presentation. WPF. Yeah, the Windows Presentation Foundation. And it was much slower than the web client. And it was reported, and reported, and reported. And 3 months later, the developers had said, it works on my machine. So we got identical laptops. We set them up on the same table. We clicked at the same time. We took videos of it. We sent it to the road blocking developer with an appropriate CC line, and it got fixed in the next couple days. Without ever running a load simulation, we were able to, and we had been running load simulations, and those were being dismissed. Well, that's not rendering time. That doesn't count. And with that video, we were able to capture, what the actual experience was. But actually, a couple times this week, I've heard that more and more people are videoing their test sessions, even like James did this morning, to help document some exploratory testing, which I think is a pretty interesting use of it, and also for documenting business cases as they prepare to automate or for load or just for checking certain business activities. There's a tool I like called Fiddler that I end up reaching for all the time that really should be paying me money by now, because it does a lot of things I really like for looking at web pages, essentially breaking down the components of those web pages and saying how long each one took and what was in them and that sort of thing. And that's something that anybody can install and run on their local computer without any sort of complicated environment or tooling problem. I encourage some of my customers sometimes to have one person log on and click on some of the common business activities. You have to be very careful and you have to trust them before we're running a load, and have them take a look at how the system performs. And that is a way to do a sort of acceptance testing with performance performance characteristics rolled in. You know, the system's loaded to where we think it's going to be. How about you interact with the software and tell me if you think it's fast enough? Some people say, yes, of course I put timers in my automation. Most people I've asked don't. So if you have GUI-based automation, you actually get better performance data than my load test does. My load test is designed to measure the effects on servers and how long it takes to get a response from a server. GUI automation actually has more of the user's experience. And this is a challenge for load testing, particularly with, as the apps get fatter and fatter. The web client software I used to test would respond in less than a second and render for the user after 2 more seconds. So I was missing most of the story. So if you're not doing this, maybe something you should consider is to start logging response times for common activities and track those over time. So even without without load, you can at least be alerted if there's some issue where your response times are increasing. It gives you a chance to detect something and drill into it. So I've kind of touched on a couple times about reporting performance results. I think that it's a little bit different for early performance results than the traditional performance test. The way I report a traditional performance test involves a lot of number crunching down to the 5, maybe 6 graphs that matter, and then some writing around each one of those and presenting that to a stakeholder. For this, you're going to talk to developers. You're going to talk to people who are on a team. They're more technically savvy, and you don't need to provide as much context. You still need to analyze your data to provide information. The biggest mistake I think most load testers make is they provide data instead of information. So tell me what I'm seeing and why it matters. If you turn over results and nobody does anything, maybe you shouldn't have bothered. Maybe if you feel like you wasted your time, maybe you did. So it should be good that if something occurs, that you can not only report it, but you can get something to happen. And use informal channels as well as formal channels for that. Some of the things I've done is sending out an email with test results to the people who are going to who should see them. And then because people don't read emails, an intranet page where you can track how things do over time. I had a big whiteboard over near my desk, and we would write stuff on there so people walking by would see it. When I first saw the Post-it boards, I thought that a big part of their value was making people look at them. I think that sort of is in the same area. All of my status reports, because I was someplace where I had to file those pretty regularly, would include test results in them, trying to increase the chances that people would see this and maybe somebody up the food chain would see it. Or if nothing else, I can at least could point to it later and say, well, I have been reporting this for a while. And gossip is a great channel to make sure people hear about things. There's going to be the one person in the office, and let's say that person's name is Eric. It's telephone, telegraph, tell Eric, and then everyone will find out, and then that's a way to get your message out. If you do this well, people will be interested in your information, and they'll come to you to find out how things are going. How's the project going? Well, I don't know. I guess the performance numbers make me feel like this. That's a good place to be. Here is an example of the kind of table I would report of a 10 by 10 load test. This is over a year, and I've crunched it down so it fit in a slide, but we had these results for some period of time. When something went badly in that second line, that actually worked really well because we'd established this infrastructure first. So when it popped up, people noticed. And by then I had already gone to the right people and presented what had changed in that software. And it was like, okay, yeah, I see. I did check that change in. I was worried about it, and that went pretty well. After that, this was a good thing to leave in all of the status reports and summaries because it made sure to remind people that we had found problems before. I know testers have to justify their value too often, but I felt like that helped. So last thing I want to talk about is testing a system that isn't complete yet. That's one of the big challenges for performance testing, is that you're expecting everything to be there. Because if the code's still changing, then maybe my results aren't valid. The other implication there is I can't test it until all the components are assembled, because it's way too early. It's way too early to performance test. I disagree. There are some ways you can start to write performance tests even when interfaces aren't complete. And by interfaces, I mean graphical interfaces. Because the interfaces that developers use, they need to have access to fairly early on. And these are a good place to put a test harness in. Developers need to test missing components all the time. How do they do that? Well, I found in some cases they already have something written that stubs out a service that you're expecting to add later. So that's a pretty well-known technique for filling in missing pieces that you probably know from regular testing. And this is stuff I just said, and we're running short on time. Okay, test what's there. I know the system isn't done yet. I can still give a history of a session model over time. I can still provide value by telling you how that's going, when it got expensive and when it's still quick. Functions that people are sensitive to and are sensitive to system load, like searches, these are good things to have tests for early on. These are things that are going to be tweaked and changed as the project goes on. You want to be able to provide some feedback if something gets bad. The simulation test tries to have a map of the whole area. We'll just stick with the highways. What are the things that most people are going to use? And go with that. Now, if you look at an Oracle AWR report, which is this report that the Oracle database gives you, for every tuning recommendation, it has this one column that says, % of use this will be affected by. So I thought it was kind of interesting. That helps guide you to the stuff that's going to affect the most people. Maybe that's a way to think about the kind of test cases you create when the software isn't complete yet. And then what's going to be meaningful to calibrate on. That will get response from your stakeholders, will get response from your developers, and it's going to be around for the life of the system. Login will always be there. So here's a sample architecture. This is a pretty standard pattern these days. Presentation layer, business layer, a few pieces, and I'm going to go through these pretty quick with some test ideas for each one of them for testing an incomplete system. So a business logic layer. This is usually where the most stuff is happening. This is where the most code is running, where there's interpreted code running. This is a place to find a problem. So get rid of the GUI layer that's going to change all the time, and just make the web service calls that the presentation layer makes to that business logic layer. An authentication store. This is something everyone who logs on is going to have to use. If you have a separate authentication store, it might be good to start testing that as soon as it's available. So how long does it take to create a session? If I try to create 10,000 sessions, do any of them crash? How many sessions can I create? What arrival rate can I support? A message bus. In a really big system, this is how your sales forces of the world are making things happen. You publish an event onto the message bus, people pick it up and they do things with it. So it's the circulatory function of that system is, can I put messages on this thing quick enough? Can I get them off quick enough? Will it support enough messages flowing through them? If there's a problem when the architecture at this stage of the game, when you're just building the system, you're going to want to fix it right away. You don't want to bake in problems to something so critical. And then, there's some back-end processing. This is old stuff to test. I ran those processes, and they're 20% faster this time. So conclusions? I don't know. There's some of the conclusions I was throwing out for you. Leave them there, and since we're short on time, let's go right to the end. I hope that you got something out of this. If you're watching at home, we know how to get involved on Twitter. This is the system of record for our community. At least that's the way it appears in 2014. If you're not a member of AST, please join. Please come next year, and you will profit. Thanks.
All right, thank you, Eric. So we'll start open season. Please hold cards high. Let me write them down and acknowledge you because I'm doing mic running and this. So, and then when I call on you, stand up so that I can find you because I probably won't remember where you are. Just one to start. Okay, 114.
Oof.
So in your talk, you didn't talk about profiling. So profiling, like if you're dealing with like C# or ASP.NET,
sure,
MVC
sure.
or whatever, using Visual Studio, or like even the Chrome or IE dev tools for JavaScript profiling, whatever, or even like the network waterfall, whatever. Where do you see profiling fit in as far as early performance testing? Do you find that as a traditional tester activity, a developer activity, or?
So at the last Whopper, we quickly identified we need to make a distinction between load testing and performance testing.
What's Whopper?
The workshop on performance and reliability I mentioned early on.
Okay.
It's a peer workshop where it's performance and reliability testers. And when we were talking about ways to get performance feedback, that's where the distinction between load testing and performance testing came in. So I briefly touched in this presentation on the idea of instrumenting automation and using Fiddler is an HTTP profiler more or less. The idea being that you can get a lot of useful performance feedback without creating a load simulation. And I think that's where I would put using a tool like a profiler. I mean, once you find a problem with a load test, or with some of the other techniques here, you need to go to a tool like a profiler if you're going to have any idea as to root cause. So I think it definitely is in there and should have been included more explicitly.
All right, we have a new thread, 76.
Thank you. How does performance testing fit into sort of production and monitoring? Like,
Fit into production and which?
into production monitoring. Like, does it sort of go straight in, or do you have to do other things?
So what I'm seeing a lot more of these days is the idea of doing monitoring after going into production, and that being a replacement for performance testing for a lot of people. Tools like Dynatrace seem to have kind of become the cutting edge, the way a lot of people are doing things. And a lot of the work I'm doing these days is older enterprise software, as opposed, because a lot of these modern systems are instrumented in a way that they are compiling performance data while they're executing, and people just use that for troubleshooting and for assessing how things are going. And sometimes there's some synthetic load, but a lot of people seem to be more than happy to just go with production monitoring and finding problems that way.
So you mentioned sort of leaving out the client at times when you want to do some testing, but let's say with mobile become a very big part, that's a big part of my life. How do you do that? Because obviously, let's say if you have one web page, for example, it won't necessarily be the same on mobile as opposed to web, so how it interprets that and then presents it to the user. How do you get around that, and where you're doing performance testing depending on changes of clients?
All right, so I have a fairly high level of ignorance about this. I will say that when I've tested mobile game platforms and things like that, I've just kind of left the client out of it because I've been testing the server, and that's maybe a shortcoming of load testing, that it focuses on, does the infrastructure support this? I'm aware of the issues with bandwidth for mobile, for example. And a lot of these load tools have a mechanism for dialing back their available bandwidth. That's going to be very crude. And there are other tools to limit bandwidth, and that's also a problem. Maybe the best recommendation I would give from my limited experience is the idea of I'm going to put load on a system and then do acceptance testing while that's happening. See, how does it perform for me now? And then there's other people here with great tricks and then we walked outside while we were playing with our phone, and then I went down into a stairwell, and then we went for a drive, and lots of ways to vary that condition. I have not seen load tools that are really good at addressing variable battery network type conditions.
All right, we have 2 threads. We have Ben with us on the same thread, and then Natalie, we'll get to in a minute, on a new thread. So,
thank you. You mentioned there was the question about monitoring in production, and we do a whole lot of monitoring in production by building in metrics into our applications. So our applications report various metrics that we care about. We even edit the access logs that are produced by our web server so that they show serve time that shows us we don't have the time it takes for a request to get to us, but we know from the time we get it till we finish sending it. We can collect that data, and then we can do testing using that data. So we can analyze that data, look for where there may be issues, or if someone reports an issue, we can go back and we can see what it is. Another use of that data is that we've had some of our developers have written little relatively simple scripts that will read in access logs produced in production and play them back for a load test so that they don't have to script all the details of a test. In some cases that works, other cases it doesn't. So if you have a lot of workflow dependencies, you can't make one request till you made another, that becomes more difficult to do. But on things that you can make your requests and exercise your systems independently without needing specific workflows, we found that can work very well.
all right, we have a new thread. Natalie?
Thanks. Okay, I think this is working. I just wanted to ask, this may be something we can talk about later, but you mentioned that you suggest Jmeter for starting with performance testing. I just want to ask if you have any specific comments on using techniques like this to get started in performance testing, because this seems like a reasonable, small, like micro experiments way to do that, especially, but for me in an environment where there may not be a whole lot of existing performance testing. So I'm interested in applying performance testing techniques, but I'm also maybe in a situation where I'm going to have to justify like looking at performance for the first time as someone who doesn't even necessarily have a whole lot of experience with it.
Right. So I think I should amend that statement and say that in many situations that's a good tool to start out with, because there are certain types of applications that you can't test easily with that kind of tool. So in the circumstances where it's appropriate, I suggested that one because it's free and really well documented, and there's a lot of help available on how to do things. These days, even HP is giving away 50 seats of Load Runner, so that might be worth an investigation if you wanted to fool around with something relatively expensive, but though you're going to have to deal with the HP rep calling you to ask how your evaluation is going. I think I have an affinity for that tool because I've tested very different applications with it. Not HTTP applications, and then applications that were polling directories. I could use Jmeter to throw stuff in there, and so I just thought it's a pretty robust framework, and it's pretty easy to get started with, I'd say.
Thanks.
Okay, any other questions?
Are
the slides available?
Will be available, correct? Oh, wait, all right. The latest I've heard on this is that the plan is to make the slides available, but there's no formal plan for that at that point. I'd be more than happy to take your email address and email them directly to you and cut all of that out. For anybody watching at home, tweet me and I'd be happy to do the same. As far as whether that's the policy for the other presentations, I couldn't tell you.
All right, thank you. We have another new thread. I'm getting a lot of exercise today. Another new thread over here, 114.
Thanks. So do you have any advice for teams that are small that don't have dedicated perf testers? So how to balance that within the normal huge workload that a typical tester has as far as functionality and stress and scale and whatever? How do we fit that in? What sort of techniques would you consider?
I think if you have people who are already doing some kind of automation, it's really easy to write it's real easy to write scripts for load testing. Like load testing, to me, the scripts look like dumb automation typically. So you have most of the skill hump right there, and the tool isn't that big of a leap anymore either. The context matters in terms of, is it a multi-user system? Is it something where you're worried about surges? If I was in e-commerce, I would be really interested in synthetic loads. If I was testing, I don't know, a simple desktop application, maybe I'd worry about it less. I don't know how helpful that is to put it that way, but even if somebody's half time or a quarter time even to write a couple simple scripts, I think you can get a long ways with, and that's kind of what I was trying to talk about here, is traditionally this was something you formed a team for, and it was a shared service, and even large organizations would have a team of people who did this and had to be shared across projects. And I think that if you approach it without trying to recreate the world and all of its glory, then you can do cheap tests that will still yield good feedback. If you have a concurrency problem, you should be able to detect that without really running a load test, without running any kind of simulation test. You should be able to detect it with crude load tests. In fact, the less think time you have and the less sophisticated your test is, the more opportunities for collision you can create.
Okay,
anywhere close to what you were looking for? Or? Yeah.
All right, we have a new thread, 104.
Given that you said that the traditional simulation test is so expensive and that you're better at finding issues with early testing, are you making the argument that you don't need that expensive simulation testing anyway, and performance testing is good enough?
No, not at all. I'm pointing out that the traditional simulation test, essentially you can't do it until you're at the very end, and it has a requirement for a hardware environment, which usually needs to be dedicated. And there are a lot of things that have to be aligned to be able to run a simulation test. And it's probably good due diligence to run a simulation test before launching a new system or launching a new product, depending on how business critical things are. I think the techniques I talked about today are things you can do without all of that being in place. Provide performance feedback, maybe even really early in the process instead of only at the end. But yeah, I think simulation tests can't go away.
All right, any other questions? All right. Then open season's over. We're done. Thank you very much.